Okay, hello. So I missed the description of this method in class yesterday, so I'm doing it today. So the real thing that needs to be understood about the paper that you will be reading for Thursday, tomorrow, is that there's a measure of something which I actually didn't have a chance to talk about in class yesterday, which is something called interference. And interference is the capacity for when there is a chromosome and then there's a span between two visible markers and two other visible markers. A crossover event in one span has a capacity to suppress the occurrence of crossover events in the other span. All right? And so the way that interference is measured, which the paper does, is they basically are measuring, in this particular case, recombination between two visible markers. And so you might have, for example, ILUS and NET and purple. These are not ones that are necessarily ones that we talk about in this paper. And you have an individual that's heterozygous for those. And these are all recessive markers. So you have wild type allele here, here, and here. And then these individual female Drosophila are going to be crossed with, and I'll put the genotype on the top, all right? It's going to be a test cross, so they're going to be crossed with individuals that would have E, or ILUS, NET, and purple, all right? Now, these alleles, E, NET, and P, are recessive, right? So being homozygous, you see the phenotype, and being heterozygous, like in this case, you wouldn't see the phenotype. And so by doing a test cross, if there's a recombination event like this, right, and this particular chromosome was recovered in the progeny of that cross, plus NET P, all right, since you're being crossed with an individual that's homozygous for all the markers, you will then, of course, see the phenotype of NET, the phenotype of purple, but this will be plus over E, and you'll end up being wild type for the ILUS phenotype. Right? So the way that the paper calculates interference then is you have a certain amount of recombination that occurs between visible markers. Right? So if we go back to this particular case here, right? E, NET, and then P, okay, and plus, plus, plus. You can measure how much recombination happens here, and a recombination of, say, for example, 20 centimorgans, and a recombination rate of 10 centimorgans, means that we expect that the frequency of recombination between here is 0.2, and the frequency of recombination here is 0.1. Right? Now, interference is, as I said, the suppression of crossing over that occurs when there's a crossing over nearby. Right? So what this means is crossovers then are not independent of each other. If there's no interference, the proportion of times you get double crossovers, a crossover here and a crossover here, you'd expect them to happen independent with one another. And if things are independent with one another, the probability of observing, say, for example, a double is just the probability of this times the probability of that. And so if we multiply those together, we would expect that 2% of the progeny would show a double crossover event. But we might observe a case in which instead of saying 2%, so this is going to be the expected, all right, the actual observed might be half of that. So we might, for example, see 0.01% of doubles in that span. And in that particular case, we measure interference based on this following equation, all right? Here in this particular case, interference is 0.5. So there's this thing called the coefficient of coincidence, all right, which is simply observed over expected. And that you do it in terms of a number, right? So if you expect, for example, a number of crosses that were done, maybe 100, if you expect, for example, or 1,000, if you expect 20 doubles, and you observe 10, the coefficient of coincidence, COC, is 0.5. And interference is equal to 1 minus the coefficient of coincidence, all right? So the point here is that if you observe 0 doubles, but you expect 20, the coefficient of coincidence is 0, and interference is 1. Alright? So interference is measured by the degree to which there's a deviation of the observed numbers of doubles based on the expected number of doubles. And if there's complete interference, doubles never occur because a crossover that happens in one span completely suppresses a crossover somewhere else. And that is a thing that is very interesting, and we still don't know how it works, but this is something that the paper will discuss. Thanks.